Awesome. Well, good morning, everybody. This is the workshop we're calling From Jupyter Notebook to Web Server, Automating Container Deployments with GitHub Actions. My name is Nick Cody. I work here for Sizzle in TDD. My job title is Technical Product Owner. So basically what that means is I work with the different user community here to figure out needs when it comes to the project that I'm working primarily on, which is the Sizzle Cloud pilot project. So again, reach out to the different scientific community to figure out different use cases for that project, do outreach, do these types of workshops. So this is a follow-up workshop to one that we ran back in June. So in that workshop, we basically went through how to build a container image file from a Jupyter notebook, how to get that working, and we went through some ways to push that up into a container registry so that you can share that with other people. So today, what we're going to be doing, there's a lot less software required than the previous time. So today, all we really need is a GitHub account and a Docker Hub account, as well as Docker or Podman, or if you have a different container engine that you like to run. This will just be validate that the image that we built through GitHub Actions is working, and we can pull it down from Docker Hub. We can run it locally on our machine. So the primary focus there is going to be the GitHub and the Docker Hub accounts. So if you don't have those, as we go through, we'll have a good time to kind of set those up. So the goals for today are going to be to work together through a notebook that handles all of the content. So what we're going to use is github.dev to add our GitHub actions. GitHub.dev is a IDE, so like an interactive development environment that works in your web browser. So it allows us all to kind of work out of the same place. We should see the same kind of screen without having to install anything, outside of just your regular internet browser. So we're going to use GitHub to build containers, and we're going to also configure it to push them to a Docker Hub container registry. This will be your own personal Docker Hub registry. So we'll go through all those steps together. And the last little bit that we'll touch about is learning about Helm charts, a little bit more Kubernetes objects, which is what are defined inside of Helm charts, in a style of automation, continuous integration, continuous deployment, referred to as GitOps, which is like a DevOps style of CI/CD, that continuous integration, continuous deployment, but working primarily out of a Git code repository. So ultimately, the end goal is to understand this process so that you can take these core concepts that we're going through and actually apply it to something that's interesting to you, that's going to be a little bit more complex than the things that we're going through, but supposed to kind of lay out the groundwork so that you can take that and move forward and use it in your day-to-day work. So to get started, there's a number of instructions in the README file that we have for this repository. I'm going to go ahead and drop the link to this repository in the Meet chat, and we're going to go ahead and open that up in our browser. So if people join in late and that link's not in the chat, I might have other people that help out and drop that link in case people need to get up to speed there. But I'm going to go ahead and open up that browser myself. I think you're right too, Nathan. Let me take a look. Awesome. That is pinned now to the top. So right now, let me make my screen just a little bit bigger. So right now I've accessed the repository that we're going to be working out of in my personal GitHub account. So this will be a little bit different. Sorry, it won't be a little bit different. I'm going to go and do that so that I can go ahead and fork the repository with everybody else and work alongside of you doing the same exact thing, instead of being the owner of the repository and that type of stuff. So to get started, once we have the repository open, we're going to go ahead and in the upper right-hand corner, there's this fork button. So we're going to go ahead and fork a copy of this repository. So this will bring up the create a new fork kind of wizard. There's an owner tab here. So just make sure this is your actual GitHub account. This is my personal account. If I was on my NCAR account, I think I would see that like I could put it in the NCAR organization. If you're a member of other organizations, they might show up in that dropdown. But just make sure you have it under your own. And then I typically like to append the repository name with my my username, just to make sure that I know that this is different than the original repository. We don't have any kind of like new name duplication or anything like that that can lead to confusion later on. So once you've got that in place, everything else, the defaults are all fine. So we're going to go ahead and create the fork. So this will just copy all the repository contents from the original one over into my my personal GitHub account. You should see the same thing. Just a note to anybody that attended the previous workshop, when you go to fork the repository, it might already exist. So if you run into that, you could either browse to the repository that you have that's already forked and try to sync the changes. If there was an issue there, you could go in and delete the previous fork and refork the repository. But so I'll give it a minute to make sure everybody has forked the repository and they're sitting at this spot. So let me know if anybody has any problems. We'll give it just a minute and then we'll jump into the notebook. Awesome. So we are going to work out of this August 8th, 2024 directory. So if we click on that, it'll open up the file browser on the left here. And we're going to go through this walkthrough Jupyter Notebook. So if we click on that, kind of gives us a rundown of everything that we're going to be talking about. So like I mentioned before, the purpose of this workshop and the notebook is to provide an example of how you could use GitHub Actions to build a container image that you can use to post on the web via Helm charts. Again, the hope is that you can take this and apply it to the work that's interesting to you. Yeah, and if you want the fork button, I can go back just a second. It's usually the same on all the repositories. So even though I've already forked this repository, the fork button shows up on the upper right for me, but it's grayed out. So that's where that fork button will be for you. Awesome. So again, we're going to go into the August 8th folder and open up the walkthrough notebook. And it goes through the prerequisites we already talked about. Really, the only ones are the GitHub account, the Docker Hub account. If you're able to fork this, you already have your GitHub account. And then if you don't have a Docker Hub account, we can deal with that when we get to that point of the walkthrough. So just a caveat, statement at the start about an introduction to containers. If you didn't attend the previous walkthrough on June 20th, that went into greater detail about what containers are. But in a nutshell, containers package software and all the dependencies into a single image that can be run on any system with a container engine installed. The container image that is created is portable. It's immutable. The software inside won't change. So this means that if you were able to run it, today, 2 years from now, 6 years from now, it will still run reliably in that same state. It'll still have the entire same software stack, same versions of software. Nothing really changes there. So I didn't want to go into great detail about that just because we covered it more in depth in the previous workshop. So if you want more information, there is a link in here that you can go back and look at. We did record that previous workshop as well. So if you want to go and watch that, there's a link on YouTube. So just a small introduction to containers. We're going to kind of sidestep that and get more into building them through GitHub automation with GitHub Actions. So to get started, we've already kind of kicked this off. We opened the original repository that I had made, and we forked that repository. Now we have our own instance of it. So once we have that all complete, what we're actually going to do is we're going to open up github.dev. And this is, again, a IDE, so a code kind of development environment that's hosted on the web. And the easiest way to open this up for what we're working through is to just go up into your URL at the top here and just change the .com, delete the .com and change that to .dev and hit enter. And that will automatically open up the walkthrough notebook in this interactive development environment. So this will allow us to add in any new folders, new files, make changes where we need to, and push those changes back up to the repository, all from the web browser. So take a minute to pause right here and make sure that everybody can open up GitHub Dev. They've got the walkthrough open, and there's no issues getting that started up. And also just questions in general at this point too. All right, so now that we have GitHub Dev open, we can start to add in some files and start looking at what GitHub Actions can actually do for us. So just a note before we get started about the on-premise cloud deployment and automation around that. I mentioned I'm the technical product owner here at NSF NCAR working on the Sizzle on-premise cloud pilot. We have set that up to use a continuous delivery tool called Argo CD. And what Argo CD does is connects to a GitHub repository and looks for a Helm chart in that repository. And what a Helm chart is it's just a set of configuration files that relate to Kubernetes objects. So these Kubernetes objects are typically like, a deployment is a set of pods that contains containers underneath those pods. The pods run containers. So the Helm chart is a infrastructure as code kind of configuration and definition of Kubernetes objects. So we're going to get into that a little bit more in depth later on after we go through GitHub Actions. But what we're going to look at is using GitHub Actions to build a working container image that runs our web server that we can use in a number of different places. But ultimately, what we're looking for is using that container image to create content for an actual website that's live at a URL that we can host, on the on-premise cloud pilot. You could take that and you could deploy it to a Kubernetes cluster at your house, AWS, on Google Cloud, Azure, a number of different places. This can kind of get ported around. It can move around. And that's one of the reasons why containers and Helm charts can be so flexible and really powerful. So at that note, we're going to move right into getting started with creating GitHub Actions workflows. So a GitHub Actions workflow is a YAML file that you add into your repository. it can do a number of different things. They can run scripts. They can run, generic commands from the command line. They can pull in pre-baked actions that are defined by the user community. So it's this really powerful tool. It's basically GitHub Actions runs on a virtual machine, a container. It can run on your laptop. It can run a number of different places. So we're going to go through a couple of those different places to run these. We're going to start with the GitHub provided machines, which they just call runners. We'll touch on self-hosted runners as well. But we're going to focus on using GitHub Actions to actually build a container image. I will make a note. The previous workshop, the container image we used was a little bit bigger, and it required the end user to download some images from, I think it was NASA, but anyways, the downloads took a little bit of time. The overall website would time out if you had a slow internet connection. So I did change the container image that we're using to one that we just recently developed during the Project Pythia hackathon a couple weeks ago. So anyways, the overall foundation of wanting to use something that was pre-baked, this all comes from the Project Pythia website. The container file is included in the work that we did there. And I actually included it in the August 8th, 2024 directory as well. So I don't want to touch on this too much because we did kind of go over it in the previous workshop more. The overall layout of this Python file or this container file is exactly the same as the previous one, with just some changes to reduce the final image size. So the previous version used Mamba. Instead, this one uses just the Python Slim version, and again, uses a different dashboard that should load faster in case you're working through this with a slower internet connection. Otherwise, the entire container image file runs, the same kind of commands, does the same thing, starts the web server the same way that we did in the previous workshop. So just a quick note that did change just slightly. So we'll be seeing a different web server when we're done here. But overall, the layout and everything is all done the same. So that being said, I think we're ready to start actually putting some stuff in place and seeing how this automation works. So before we do that, I'll give one quick minute for any questions, if there's any at this point. Otherwise, we'll start getting some things in place. Awesome. So all of our GitHub Actions workflows need to be defined and live in a certain directory. So GitHub will always look for these Actions workflows out of the .github/workflows directory. So that doesn't exist by default. So to get started, we actually need to add that directory into repository. So if you just go over onto the left side here, you can either there's a little new folder button at the top, or you can right click and just select new folder. So if we do that, we just have to do .github. And then if we have to right click on that .github, or you can use the new folder button again up top, we'll add another one called workflows. So this is where any GitHub action that we define would live. Again, you can have a number of different GitHub actions. They can run different jobs. They're really beneficial for running tests before you merge changes into your main branch, things like that. So we'll talk about that specifically for this first example that we're going to walk through. So we're going to do the first example that we're going to work through is just building a container image with GitHub Actions. We're not going to push it to a container registry. We're just going to build the container image, see how that runs, see how it gets added in, walk through each line of the YAML file to kind of understand what we're defining there, and just see how it all kind of works. So again, sometimes it's advantageous to just build an image but not push it anywhere. So for instance, you're working out a development branch in your repository, you're making a bunch of changes to your container file, maybe you have to update some software versions. So you made all these changes, you're not sure if that container image is going to build properly or not. So you might want to test that those changes that you made work properly before you go ahead and build the image and push it to container registries and those types of things. So this is just an example of that kind of workflow. So to get started with that, we're going to go back ahead over on the left, and under workflow, we're going to right click and we're going to add a new file this time. And this will be our first kind of GitHub Actions workflow. So I like to use a descriptive name for each one of my actions. So this one's just going to be a build test. So we can just call it web app build test.yaml. And if you hit enter, it'll create that file. And to save us some time, if you go ahead in the notebook, there's a pre-built YAML file. So just make sure we're going to copy and paste that into the new YAML that we just created. But make sure when you grab all that, you're not actually grabbing the little three ticks, the little three backticks that I use to actually define this as code in the notebook. So we want to just start from the top comment where we name the action down to the bottom. The last bit is this tags section. So we're going to go ahead back over to our new YAML file and paste that in. And then I'll spend some time going through the lines here so we can understand what's going on in this YAML file, what we're doing, and why we're doing it. So the first step is going to be to name the action. So we just go ahead and we do name with a colon and say, hey, this is automation to build a container image. This can, be whatever you want, but this will show up in your actions when you run this. This is the name of the job that pops up. If the job were to fail, you would get an email from GitHub saying automation to build a container image failed, that type of stuff. So again, we want it to be descriptive of what we're trying to do. For your own, workflows, this might be a little bit more in detail. It might be less, whatever you want to do. So first step is the name. Second step is to define when we want this action workflow to run. So what we do for this is we start with the on command. So line 5 right here, you'll see on colon. So we're going to do this on a push. So the next line is that push colon. There's a number of different definitions. You could do pull request. You can set this up a number of different ways. We're just going to do it on a push. And what we're going to look for is anytime there's a change made to this particular path, so the August 8th, 2024 directory on the main branch. So you could change this to be development branch, feature branches. You can leave the paths part out. So any change made to the repo, you could go into further directory. You could make it so it only ran when there's a change to the container file. So you can set this up kind of any way that you want to, and fine tune when you want the action to run. So after we define when we want the action to run, the next step is to define the jobs that we want to run. So the job that we define can have multiple steps, and an action can contain multiple jobs as well. So this example uses one job with multiple steps. But again, you could have one afterwards that maybe a job to run a shell script command or anything like that. So once we kind of define our first job, this one's going to be called build image. So that first line of the job's description becomes the job name. So this first job, the only job that we're running here is going to be called build image. The next step is to define where we actually want to run this job. So GitHub provides some virtual machines that you can run these jobs on. I believe they've got up to about 10 gigs of memory, around the same in terms of space. So for small jobs, small workflows, they work really well. They're relatively fast. You don't really need to worry about configuring too much. So they work really well. We're going to run this job on the latest Ubuntu image. GitHub does provide a Windows image and a Mac OS image. So if you're trying to do, cross-platform testing, for whatever you're trying to do, it's pretty nice that you can run on those different operating systems. So anyways, once we define where we want to run this job, next is the steps to actually take for what we want to do. So the very first step is going to be to check out the code that we have in our repository, because that contains the container file that we actually want to build, the relevant code that we're trying to use. So that's the most up-to-date stuff. We want to make sure that we're pulling that. And so what we're going to do is we're going to just name that step. So this is just check out the repo step, and then we're going to define what it uses. So this case, we're going to use a pre-built job defined by the GitHub Actions community. This is an official one from the GitHub Actions team, just called checkout. And we'll use, they have different versions. So we'll use the latest version, which is checkout version 4. But this is basically going to just check out our repository. And it's going to check out the main branch. You can specify if you wanted to check out a development branch or something like that with a additional command that's just with, which we'll see down here in step 3. But so step 1 will run, that'll check out the repository. We have all the code that we need now on our GitHub provided runner. The second step that we're going to do is we're going to get the current time and date. And we're going to use this and send it to GitHub output. And we're going to use this to apply as our container image tag. And there's a number of different ways that you can handle this. I've been using the date just because it's relatively straightforward. It gives me a unique tag that has some kind of meaning behind it that I can use for my container image. You could tie this into like a GitHub release as well. So if you were doing different software releases and things like that, you could use that instead. But what we're trying to avoid here is using the latest image tag. And the reason for that is when defining like a Helm chart that uses an image, if we use, Nix container :latest as the image tag, when I build a new container, that image name stays the same. So my Helm chart never really changes, even though, that latest image changes, the text never changes. So like my continuous deployment tools might never see that there's an actual change. So my application never gets updated. So using the latest tag, for one-offs and everything is fine, but in best practice, you should really be using container image tags that are more descriptive, more pinned towards specific versions, just to do some additional version control and making sure that, again, if we change things, we can update it, and any kind of continuous deployment tool or something that we might use realizes that, hey, we switched versions, we need to update what we're doing. So that's why we're grabbing the date. And you'll see that throughout the workflows that we're going through. So step 3 is going to be when we actually build the Docker image. So this gets a name as well, and it uses a GitHub action that's defined by the Docker team. And that action is called build push action, and we're using version 4 again. So this does have a push mechanism in it. You can see down here on line 34, we have that set to false. So we're not going to push it to Docker Hub. In order to push to Docker Hub, we need to provide the workflow username and token, which we will do in the next step. But for this one, we're just going to test this build, make sure that the container image that I provided you all works. We don't have any issues with the setup here. So just to touch on that, we use this with command to provide some additional steps to this action. And a lot of this is, build flags that you would, provide in your regular Docker build commands or podman build commands, right? So the context is, where is this container file? Where are we building it out of? So the container file that we're building resides in the August 8th, 2024 directory. So we provide that with the dot. The next line is the file that we want to build. So again, that's the August 8th, 2024 directory, and it's called container file. We don't want to push the image. And then the next is actually what are we going to tag this image with. So by default, we're using the Docker action here. So by default, it will get the prefix will be docker.io/, and then it will be your Docker Hub registry name. So this is typically like your username. What I have provided here is actually my work Docker Hub, and that's different than my personal one that I'm walking through this workshop with. So you all need to change this line along with me so that it uses your actual Docker Hub username. If you don't know that right now, that's fine, because we're just going to build this image. It will get a tag, but we're not going to push it anywhere. So if you don't know right now, we can just leave this the way that it is. If you know, go ahead. Feel free to update it. Thomas, go ahead.
Is your Docker username the same as your Docker Hub username? Okay.
I think so.
Okay.
I can't guarantee that, but I'm pretty sure that it is.
Okay, cool.
But again, we're gonna in the next step, when we push the image to Docker Hub, we're gonna need to grab a API token. So we'll have to log in. We'll be able to see what our username is at that point. We'll need to provide GitHub Actions with that username as well. So we'll go through those steps. So again, if you're not sure, feel free to put whatever you want in this tag section. But so I'll go ahead and update mine to my personal tag. That's my GitHub registry. Then the next / workshop-web app is the container image name. And then we have this colon with the $sign and then the double curly braces with this variable inside. So if we look at the variable, it says steps, which is, we're from the steps part of the actions workflow .date, which is going to look at this ID that we set back up ahead, grab the date ID. From that, I want the outputs and I want the date, which is actually what we set in here, right? We ran echo date equals the date, and we pipe that out to the GitHub output. So that's where we're grabbing that from. That's how we define that variable. So if you were to change the ID, it would be the second part here in between the periods. And if you were to change this date on the run side, that'd be the last kind of part there. So anyways, that's a basic GitHub Actions workflow file that will build a container image for us out of the repository we're working out of. So before we push this workflow file to the repository, are there any questions about the workflow file, what we're doing here, or anything else that we've got going on? Awesome. So like I mentioned, the next step is going to be to actually put this workflow file into our repository. As soon as we do that, it will register itself as a GitHub action. And whenever we push a change to the August 8th directory, it will fire off that job. So in order to push these changes, GitHub Dev has this nice little source control icon here on the left. Looks like a branch. So this is the GitHub extension. We can see it's got one change pending on it. That's why it's got this little blue button right there. So if we go and we click on that, we can add a commit message. So we'll just say add build test workflow. Close this, and underneath that is a commit and push button. So once we've got our commit message in there, we hit the commit and push. And that's actually added those changes to our repository. So over here on the left, the upper left-hand corner is this little burger kind of menu. If you click on that, there's a go to repository link, and that should open in a new tab. So if I go back over to the repository, we can see, oh, hey, there's this new GitHub workflows directory that was just committed now. If I click into there, here's my actions workflow. So it's awesome. We've got that in there. Now let's go ahead and fire off a test job. So what we have to do, let's go back over to the Explorer. So over in the upper left-hand corner, there's that 2 pieces of paper icon. Let's click on that to go back over. And let's open up the container file in the August 8th, 2024 directory. And let's just go ahead and add a comment in at the top. So this just be whatever you want. We just want to make a change to the file so that when we push it, it will, GitHub will recognize that, hey, we changed the file in this directory. I need to run this GitHub action. So I'm just going to say Nick made a change. If we look back over on the left again, the source control has a little blue circle with this 1 in it, meaning, hey, I've got a new change. So we click on that, go ahead and say change to fire off GitHub actions, whatever you want for your commit message. Should work. And then once I click the commit and push button, that will be a change in the repository, in the directory we specified for our GitHub actions, and then that will start our GitHub actions. So as soon as I commit and push this, we're going to switch back over to the repository, and we're going to watch the action kind of go through the steps. So whenever you're ready, go ahead and click that commit and push button. Switch back over to the repository tab. Again, if you don't have it open, you can use that burger menu on the upper left. In the repository at the top bar, this third one over from the left is actions. We're going to click on that. And this is going to show us all of our workflows. And we'll see we've got one workflow run in progress. It's got this little yellow circle that's spinning. So this is actually working. We can click on that. It'll tell us what job is running currently. So we have the build image job running. And we can click on that, and it'll actually show us all of the steps that's going through. So I'm going to make this a little bit smaller, just so you can see. So we are at the build Docker image step. That's the last step that we had in our workflow. There's going to be a decent amount of output for that build Docker image. But if we just scroll to the bottom, we can kind of see how it's going through, doing its thing. If there were to be an issue, this is the logs that we would be able to reference to go back and see, hey, what is that issue? Maybe we had a typo in our requirements file, and the package that we're trying to install didn't get installed because we had that typo. This is kind of where you would see that output, be able to do some troubleshooting. I did go through all of this, so we shouldn't hit any issues with this particular build. But anyways, that's just where you would see, if there were any kind of problems. So we can see at the bottom here, it's finished building that Docker image. Here's the name that it provided. So we can see, like I mentioned earlier, it automatically adds that docker.io prefix. If we wanted to push it to a different container registry, we can add that in ourselves. It'll override the docker.io. So if you wanted to use like key.io or GCR or whatever you wanted, you could put that in there. And you can see that it actually did as well take our date and actually set that instead of the variable that we got. So we've got, August 8th, 2024, and we're in hour 15 based off of the time, this GitHub runner is living in. So that's pretty much the end of the action workflow. You can see over here on the left, we've got a nice green check. This job ran successfully. It took us a minute and 30 seconds. We can click back over to the build image. It kind of gives you a summary of what happened. If we click back on the actions workflow, we'll see, hey, this one workflow run. It'll tell you I ran this job. It was run out of the main branch. It'll tell you the commit that fired the job off, all of that good stuff. So that's our first actions workflow. Again, it built the Docker image. We didn't push that anywhere. So just making sure that all runs good. So we're going to disable this workflow, but any questions before we do that? Awesome. So we're going to disable this workflow because we're going to be adding some additional workflows that run under the same conditions. And instead of having multiple actions that kick off at the same time, we're just going to isolate it down to the ones that we care about. So go ahead and click on this automation to build a container image job over on the left side, or whatever you named your job. And then if we go over to the top right hand, there's this 3 dots button. And if we click on that, it'll give us kind of 3 options. There's a create a status badge option. This is really cool. Actually, I do it for a lot of my repositories where I have a lot of GitHub actions. You can create a status badge to include in your README file so that when you open the repository, it'll automatically kind of show you the status of all of your actions workflow, and at least that you've added the badges for. So I can create a status badge, add it to the README file for this automation to build a container image. And it would show me, the last job ran successfully, that type of thing. And pin the workflow, but what we're interested in is disabling the workflow. So go ahead and click the disable workflow button. It'll show up, this workflow is disabled manually. If we click on actions again, you can see now in the name over here on the left, right to the right of it says disabled. So what we're going to do next is we're going to go ahead and we're going to add a actions workflow to build the image and push it to Docker Hub. So if we go back over, go ahead, Brian.
Yeah, so when you disable the workflow there, that my assumption is that doesn't get reflected in the actual repository at all, does it? Like if you were to say clone it, there'd be no sign that it's disabled?
That's a good question. I haven't ever seen, it's not part of the YAML file. It's not part of that configuration. So I think if I were to disable that workflow and fork it, it's a really good question. I don't have an answer for that. So it's something that we might want to kick the tires on later just to get a concrete answer.
Okay. Sounds good.
Yeah. I would think that maybe it's in like some metadata underneath the covers. So if you cloned the repository or forked the repository with a disabled workflow, I would think that would carry over. But I don't know for sure. So I think that's something that we could potentially test here.
Yeah, the forking scenario is kind of what I was thinking about. Like if you kind of wanted it configured in a way that people, when they forked it, they didn't immediately trigger a bunch of workflows.
Yeah, exactly. Or if you had a job that was broken or something that was really compute intensive or something like that you wanted to keep off. But really good question. Thanks for that. So, all right. At this point, we're going to go back into the github.dev IDE, and we're going to add another GitHub Actions workflow to build and push the action. So we scroll down a little bit. We already went ahead and we tested the new workflow. So we've got this header here that's build and can push a container image. So basically, once we know that the image is building correctly, we can go ahead and push that image to a container registry. And in that case, we can share it with other people. Maybe you're somebody like me that runs multiple laptops, and, maybe I switch from my Windows machine to my MacBook, and I want to run a container that I built on my Windows machine. It's an easy way for me to pull this down onto my MacBook without having to rebuild the image, these types of things. Makes it a lot easier to share with other people too. If you're writing a paper, you could say, hey, this is the container image. It's stored in this public repository. This is how you would use it. And you would know that the user reading your paper would be able to follow along and run your container image based off the instructions you provide them. So what we need, though, in order to push our container image to Docker Hub is our Docker Hub username and our Docker Hub API token. And we actually need to add those into the repository as GitHub Actions secrets. So let's go ahead and open up Docker Hub. I did include a link for it right here. So if you click that link, it should just open up in a new window. And in the upper right-hand corner, there's a button to sign in. Mine auto-populates. I believe that it'll also let you sign in with your Google ID if you wanted to do that directly. But anyways, I'm going to go ahead and sign in with my personal email address. And it looks like it's bringing me, so you can log in with GitHub. You can log in with Google. I'm sure there's a couple other options as well. It looks like it brought me to the last place that I was. Instead of just like my repositories, and of course I clicked the logo, which is for the Docker website. So if I just go back to hub.docker, once I'm logged in, it'll bring me back to my repositories. So again, this is my personal Docker Hub. So it's got some of my own little side projects and stuff like that. And the test web app that I pushed in here. So as I mentioned earlier, we're going to want to grab our repository name. So over here in this drop-down menu, you can see for my account, my personal one, I call it NC Ginge. So that's my account name, my repository. I would use that in place of Encoding in the example that we did previously. We're going to end up with the same thing in the example we're going to be working on. So make sure that you get your account name so that you know what to update when we actually do the build and push. We're also going to need to set this as the Docker Hub username in our repositories action secrets. So we're also going to need a API token. So the best way to grab that is on the upper right. You'll see this big circle icon. Again, mine has an N in it. That's my username. So whatever your username or your account starts with, you'll see that letter. So click on that and go down to the account settings section. That'll open up in a new window. And we're going to scroll down a little bit. And we're going to want a personal access token. So if you click on that personal access token, it'll bring up a spot where we can actually generate a new token. So that's what we're going to want to do. GitHub is really nice when it comes to doing tokens. It'll let you set a expiration date for your token, which is really best practice because these personal access tokens can be used. Again, we get to set the scope here, but the scope that we're going to want is read and write access. So this token will have write access to our registry. So I typically like to rotate these out every 90 days, even shorter than that, 30 days, to make sure that if I were to accidentally put this token in a code repository, put it in plain text somewhere, I could go in and know that token is going to be rotated out and only lives for a certain amount of time. Docker Hub does not do that. The token never expires. So I will recommend that once we finish here today, go back into this page on the right. You can either deactivate a token. I would just say, straight up delete the token if you're not going to use it after today, just to make sure that, it can't get into the wrong hands, that kind of thing. It's really probably not going to be an issue, but that is best practice when it comes to managing these tokens, doing that kind of thing. You don't want to just have them out there forever. Anyways, we're going to click this generate a new token button. We'll give it a name. So again, the one I gave before was workshop token. I'm going to call this one new workshop token. Whatever you all want to do to give it a descriptive name so that you know, hey, I used this token for that workshop that I took with Nick on August 8th. And then in the access permissions, we want to give it read-write access because we need it to be able to write the new container image when we go to push it. I typically don't like to give my tokens delete access. If I'm going to delete something, I'll probably come in here and do it manually. So anyways, once we have that in place, click the generate button. That'll go ahead and spit out how we would use that to log in with Docker CLI command. We don't use that in the GitHub Actions workflow that we're doing right now. We're going to go through a self-hosted runner example that will use the login command. So we'll use a very similar syntax, but this personal access token on the bottom, we're going to want to copy that. And we're going to want to take that back over to our repository and add it as a repository secret. So go ahead and go back to the actual code repository. Mine's still open on the Actions tab, but we're interested in going to the Settings tab up here on the top. So once you're in that repository, the actual code repository, not the IDE, click on the Settings. That'll bring up just our repository settings. And over here on the left, if we scroll down a little bit, we'll see security. Then underneath security, the very last one, there's secrets and variables. And if we expand that, this top one is GitHub Actions. So this is where we can define secrets and variables that we want to use inside of our Actions workflows. So we want to use a repository secret in our Actions workflow. So we're going to click on this new repository secret button, and we're going to add one in. So the API token for Docker Hub, the way I reference it in the file that I created that we're going to copy and paste is Docker Hub _token, all capitals. So feel free to use Docker Hub _token to put your token in. If you do change that to something else, just to make a note of it, because we would update the workflow file to reference that variable. So I'll point that out when we get there, but go ahead and paste that Docker Hub token into the secret and then click the add secret button. So what this does is it adds in that GitHub or that Docker Hub token as a secret variable. This is always encrypted. When you run it through the Actions workflow, you never see it in plain text. You can never get this variable out in plain text ever again. So if you wanted to come and reference this, to use for your own, maybe in a command line or something like that, you will not be able to pull this token out and look at it again. So that's really nice to know from a security standpoint, right? Like whatever we're putting in here is encrypted. You won't be able to get it in plain text. When you look at it through the Actions running, it gets starred out. If you were to do an echo of the Docker Hub token, for instance, in your Actions workflow to see what that token is, it doesn't display it. It's always hidden from the user after that's added in as a repository secret. So again, if you're working with other people in your repository, that type of thing, you want to make sure this doesn't get out to anybody else. So again, just a really nice thing to know about the repository secrets, that they're always encrypted. You don't need to be worried about it. And that's kind of what it says up above here. Again, so the secrets are encrypted. They have this other thing called variables. Those are plain text variables. So again, if you wanted to have some flexibility in your workflows that maybe you could share them and reuse them with some custom variables that you weren't sensitive, you would use that instead. But we're using secret information, and so we're going to use the repository secrets instead. So we've got the Docker Hub underscore token variable set. The other one that we reference is going to be the Docker Hub underscore username. So again, this is going to be that repository name for your user account. So this will be your username. If you're not sure what that is, again, it'll be in this drop down here on the upper left, or in the upper right. You can click the big circle and it's displayed right here underneath. So again, mine's NCGinge. I'm going to take that, add it as an action secret for Docker Hub underscore username, all caps, add that in. And now I have login information for Docker Hub for this repository. So what this means is basically the GitHub Actions workflow that I set can use these secrets to log into Docker Hub for me and push the image to my Docker Hub account. So give everybody a minute to make sure we get that in place and provide an opportunity to ask questions if anybody has questions about what we're doing with these secrets, why we need them, anything like that. Awesome. So at this point, we're going to create another new actions workflow. So let's go back over to the github.dev IDE. And again, kind of just look at where we're at. We're going to add this workflow to build and push a container. And we're going to add a new workflow file to GitHub workflows like we did previously, but we're going to give it a new name. But that workflow file will recover. That workflow file is going to require Docker Hub username and Docker Hub token that we just added in our repository as action secrets. So now that those are in place, let's go ahead and create a new file under the workflows. So again, go back over to the file explorer, right click on the workflows to add a new file. And we can call this one, something like web app -build and /push.env. So that creates a new actions workflow for us. We're going to go ahead and do like we did previously and copy and paste all of these contents into that file. And then we'll just quickly breeze through the stuff that we've already covered. So again, the name that we have here is actually the same name that we used before. Automation to build a container image. So I'm just going to add and push to that one. The action is going to be run exactly the same. So anytime we push to the main branch inside the August 8th, 2024 directory, this action is going to run. The jobs are going to start off the same. So we're going to use the latest Ubuntu image to run the job. The first step that we're going to do is actually check out the repository the same way we did before. But the second step that we're going to run is to log in to Docker Hub. So this is where we're going to actually reference those secrets that we just added. And we're going to use, again, an official Docker actions command. And this one's called login action, which you can see right here on line 21. So the only thing that we need to provide there is we use this with command on line 24. And we provide username. And again, we use $sign with double curly braces. And we reference the secrets by just doing all lowercase secrets dot, and then the secret name that we're actually referencing. So in this case, the username is secrets.dockerhub_username. The password is going to be secrets.dockerhub_token. So step 3, we're going to grab the date the same way that we did before to make sure that we have a unique image tag. Step 4 is going to be pretty much the same as we did before as well, except line 40, we had push equals false on the previous job. This time we actually want to push the image to Docker Hub. So we're going to push equals true. So that is the only real big change. So, we've got the extra step here to log into Docker Hub, and then we're going to change push to be true. So the last thing that we're going to do before we go ahead and commit these changes to the repository is we're going to make sure that the image registry that we're using is going to be for our personal accounts. So again, instead of ncody, my personal one is ncginge. You would put in your own registry name that we grabbed earlier. This will be the same thing as your Docker Hub username. I'm pretty sure if you wanted to as well, you could just copy this variable and use that instead of hard coding the Docker Hub username, which would be a little bit more of a efficient way than having you all go in and change that line. But I did want to call that out, so that's why that's in place. So once you update that, if you wanted to, you could change the image name as well. I'm just going to leave it as Workshop Web App. But at this point, the new GitHub Actions is complete. We can go back over to the GitHub extension here, the source control, add a commit message. So add, build, and push. Workflow. And we'll go ahead and commit those changes. So we'll just commit and push those directly to the main branch. Because we did not make any changes to the August 8th directory, if we go actually back to the Actions tab, we see no jobs fired off. Our other job is still disabled, but now we see the new job listed there, right? Automation to build and push a container image. So in order to trigger that build, let's go back to the container file. So if you don't have it open, you can just go back to the August 8th directory and click on that file. And we just want to change that somehow. So you can either add to the comment you made before. I'm just going to go ahead and delete the comment I made before. Delete that comment. I can see the source control says there's a pending change. And I can just say, let's trigger the workflow under the action. We're going to go ahead and commit and push. And that will fire off the new job. So if we go back over to the repository, click on this Actions tab again, we can see we've got this trigger workflow. It's queued up. Now it's in progress and it's running on one of the Ubuntu latest GitHub provided runners. So again, if we click into the actual job, it'll show us kind of what's going on. This will take a minute just to run through and build the image again. Every time you're running one of these actions, it's spinning up an Ubuntu latest runner for you. So if you've done, previous builds, stuff like that, none of that is cached. You're starting off with a brand new, fresh image every time. So give this a little bit of time to run and finish. When it's done, we'll see that it's populated in our Docker Hub container registries. And if we want to kind of test out that it's in there, we can run it directly from our command line on our laptops or your personal computers. And we can see that it'll pull it down, it'll run it, and everything kind of worked. So while we're waiting for this build to finish, I'll take a minute. If anybody's got any questions up to this point.
So should we be seeing anything on Docker?
Not yet.
Okay.
Yep. So you will see that will be part of the steps here. So the build Docker image job, or the build image step as part of our job includes pushing that image. So right now on my screen, you can see it's actually pushing that image. So it's pushing the layers up to Docker Hub right now. So I'm not going to see that image show up in my Docker Hub until that pushing layers is all done. But it should tell me kind of at the end here that the push was successful. And then when we go over to Docker Hub, we'll see that it's in there. So these are the last couple of cleanup steps. You can see in the upper left, I got the green check mark. So this means that the build image job ran successfully. again, we can see the pushing layers was all finished. If I wanted to, I could, grab the, different information outputted here. There's some metadata and stuff that's included. But if I go back over to my Docker Hub, if I refresh this page, we'll see, hey, this workshop web app last push was 1 minute ago. And if I click in there, I can see the different tags here. So this 2024-0808.16 is the image that we just built in the workflow. So this is the new image. And if I go back over to the IDE, go to the walkthrough, scroll down a little bit. We already tested the new workflow. We made a change. We pushed that. We've got the new image up in Docker Hub. But what if we wanted to actually pull that down and run it, right? We could provide a command like this one, which is Docker run with the port 5006 maps to 5006. I know that this image that we're running is a panel web server. So that panel by default runs on port 5006. So basically that -p, I'm mapping the container port to my actual host port. So if I wanted to access this web server, I would go to localhost :5006, and it would navigate to that port and open that up in my browser. So if you're interested, you can go ahead and copy that out. This. So if we wanted to, we could do a Docker run. Again, I changed into my own. So if you wanted to test your own build, it would be the same up to Docker IO. Then it would be / your registry name / workshop -web app. And then it would be the image tag would be 2024-08-08. And then mine got tagged with .16. Again, that's the hour on the 24-hour clock that the Ubuntu runner that I ran this on had when it tagged that image. So if you were going to run this on your own laptops to test, again, you just want to make sure that the full image name that you're running matches what you see in your container registry. So if I hit OK, it's going to say, hey, I can't find that image locally. I didn't build that on my local machine, so it doesn't actually exist. So it's going to actually go to Docker Hub and pull it down onto my local machine and run it for me. So I'm going to go ahead and run through that steps just to show everybody that, hey, it does exist out there. This is how you would run it. And again, this is also why I kind of rebuilt the image that we're using for today. So it's a little bit smaller in case you have a slower internet connection, things like that. It should still pull down pretty quickly. And then we can see, hey, this, it pulled the image down, then it started it, and it's running it. So it's running this bouquet server. It's got right here, the bouquet app is running at localhost port 5006. If I want to, I can control click that link. And sorry, let me switch over and share that tab with all of you. And then this is the container running in my browser. So this is the actual Jupyter notebook that we ran through for Project Pythia. It's a temperature anomaly plot. We're basically plotting the 2-meter surface temperature variable difference from a baseline just to create an interactive plot, that we can share with other people. So, and this is the container image we just built. Pulled this right down from the Docker repository, right from my container registry. So this is the brand new container image. You can pull it down from the container registry that you push to. I could also give you the command that I just ran. You could run it on your machine as long as you have Docker Podman. Again, Docker and Podman, I didn't touch on this earlier, are basically interchangeable. So instead of doing Docker run, you can do Podman run, and it would work exactly the same as this. And again, this is kind of the end goal, right? Was to get this container image built with this interactive web visualization that, again, we can share with other people. We've got now, if I wanted to add in additional variables, those types of things, I can do that and rebuild the container image. It makes for a really nice development environment. Again, I can share that code repository with other people so that while we're doing those changes and everything, it's building a new container image with those changes, running through some tests, making sure that everything works. So I think that being said, we've reached a good spot to take a little bit of a break. If people want to take just a short bathroom break, I think we'll just take 5 minutes and we'll get back at 10:23 a.m. Mountain Time. Get some water, those types of things. And again, if you got questions and stuff too, I'll take those right now. Otherwise, I'll be hanging out, but we'll get started again at 10:23. All right, I'll be right back too. All right. It is 10:23, so we're going to go ahead and get started again. So at this point, we've gone through just, building a container image is like a test case. We've gone through building a container image and actually pushing it up to a repository. The other thing I wanted to touch on just briefly is using a self-hosted GitHub runner. So far, we've used the Ubuntu latest image that's provided by GitHub. And it's really nice if you're doing things that don't require a lot of memory or a lot of space. But if you're trying to do some more complicated things, or you're trying to build some bigger images, for instance, I've been doing some Jupyter Hub container images that have some GPU packages on them that are just too big to build on the GitHub runner. So what ended up happening was I tried to do it on the Ubuntu latest image. I would take up all the memory on the machine and it would kill itself, and my job would fail. So what I ended up doing was taking a look at using self-hosted GitHub runners instead to basically run on my own machine, or run on a different machine that provides more memory, more disk space. Maybe again, I'm using something that I need actual access to GPUs for, those types of things. And the self-hosted GitHub runner was a really good way to set this up. So GitHub provides you with a number of instructions. And if I actually go over to this repository and go into the settings, the repository settings over here on the left under code and automation, there's a drop down for actions. And then underneath actions is a tab for runners. So you can see there's no runners currently configured for this repository. I haven't set one up. That's something that we're going to go through. But if I were to click this new self-hosted runner button, it's going to give me a couple different options. Again, I get to pick out my operating system and the architecture. Again, if I'm running a different processor, what have you. The instructions will be a little bit different, but it basically provides instructions how you could set this up to make your personal machine a self-hosted runner. So what I ended up doing was I went and got the Linux instructions, and I built a self-hosted runner inside of a container. So this makes it like a portable self-hosted runner. It uses Podman under the covers. I've really been trying to use it as like a rootless Podman way to be able to build container images without having root access or having to provide root access. Rootless Podman, you need, in order to run rootless Podman though, you actually have to configure your system with a couple of different configurations to enable that. So in the example that we're going to go through, we're going to use the self-hosted runner image that I created, but we have to run it with a privileged flag for now. Again, that just bypasses, the rootless Podman setup that we need to go through on our laptops. It'd be different for different operating systems. So to kind of cut through the complexity there, we're going to run this self-hosted runner via Docker or Podman with a privileged flag. So I did just want to, take a minute to show you all that there is this runner's piece in the settings here that provides these instructions. So if you were interested in going through this on your own, this is where you would grab those instructions and kind of set those up. I did include the Podman runner configuration in the code repository for this workshop. So back in the IDE, you can see back at the GitHub dev, if I expand this Podman runner directory, there's a Docker file that's in there. This is the Docker file that I use to build the self-hosted GitHub runner. So you can kind of see the different packages I installed in there. Some of these might be a little bit more specific to something else that I was doing. But more or less, this was done following the instructions that we were just looking at for a Linux machine. And really, the juicy part as it comes to GitHub and connecting into GitHub, it's really these lines right down here. So this will install the GitHub runner requirements. It pulls them down directly from GitHub. It untars them, installs them all into the container image when this is built. There's also a start shell script over here. So this more or less kind of goes through the steps of once you fire off the self-hosted runner, it will run this start script. It uses an API token that we actually have to supply at runtime to reach out to GitHub in order to get a self-hosted runner registration token. So in order to run the self-hosted runner, we actually need to provide it two environment variables. One is the repository address that we actually want to connect it to. And then the other, again, is an API token. So if we go back to the walkthrough, you'll see kind of an explanation of what I just talked about. Again, we've got a custom container image that already uses Podman to do builds. So instead of rebuilding that, we're just going to go ahead and run the one that I've already got. But we do need to grab a personal access token from GitHub. So there's a link in here that says see personal access tokens. This link will work for everybody. Trying to find the API tokens inside of GitHub can be actually kind of confusing. So if you want, click on that link. That'll take you right to where you define a new token. I'm actually going to show you how to get there just via the browser. If you're in GitHub, go to your icon, your user icon in the upper right hand corner here. Left click on it, and at the very bottom, or close to the very bottom, is this settings. So this will be the settings for your personal account. Click on that. Then over on the left menu, at the very bottom of this one, is this developer settings link. So inside this developer settings is where we can create new personal access tokens. There are fine-grained tokens, which you can scope down to just specific repositories. It gets a little bit more complicated for what we're trying to do here. So we're just going to create a personal, a classic token, which would give access to all of the repositories that you have in your own account. But we do get to scope out what level of access we want that token to have. So in the upper right-hand corner, we're going to click on this generate a new token, and we're going to go ahead and we're going to do generate new token classic instead of the beta new token fine-grained one. So click on that. It might ask you for your password. Once you confirm that, it'll bring us in to define this token. So again, I like to create a descriptive token. So you can see I've run through this before. So we'll just do MBViz workshop. Again, whatever you want to use to make it descriptive for your own. And then, like I mentioned, when we were working at the Docker Hub tokens, Docker Hub doesn't allow you to set an expiration, but GitHub does. And this is really nice. Again, rotating your tokens frequently is really best practice for security, especially if you're working on systems that are critical to business operations, those types of things. Even if you potentially are using this to do some public cloud stuff, if somebody were to get access to your token, they could use it to do some bad things and potentially, rack up a big bill on your public cloud or something like that. So setting a decent expiration date here is important. And so since I'm only using this for today, go ahead and I'll set a custom one, and I'm going to say just have it expire tomorrow. So, and because we're running these self-hosted runners out of our own personal repositories, the only scope that we need to give the access token access to is the repo. So if we just click that repo button, that should be everything that we needed to do. We're not updating the workflows or anything like that. So I don't believe that we need to select those. If we were to create this token and needed to add in additional scopes after the fact, we can edit the token to add those in without changing the token that we're assigned. The actual token that we get will just update. So anyways, set the expiration date, make sure you select the repo scope, and then at the very bottom, just go ahead and generate that token. This will be the only time that it shows you the token. So make sure you copy it now. I tend to like to save the tokens that I use in like my bash RC file or someplace like that. Again, just so I can reference it as like an environment variable or something instead of having to actually supply it in the command line. So anyways, what we're going to use this for is this next little command right here to start a self-hosted runner. So we're going to start the self-hosted runner ahead of time to make sure that it's actually connected to our repository, so that when we kick this job off, it doesn't actually just sit there and wait and wait and wait for a runner to come online. So if you copied that token, paste it somewhere else for the meantime. I'm just going to go ahead and put mine on the browser up here. And I'm going to go ahead and copy this Docker run command that I have listed here. So again, if you prefer Podman and you're using Podman instead of Docker, just change that first little blip to be Podman run instead of Docker run. Go ahead and share my command line with you all. So this is still running the container from before. So I'm just going to Control-C, interrupt that, shut down that container image, clear that out. And I'm going to paste in the Docker run command I just copied. So we need to change two things in this command so that it will work for you all. The first thing we're going to change is the repo. So this is not going to be the full URL for your repository. It basically is just your username or your organization's name, and then / the repository name. So this is basically, like after github.com or after github.dev. Mine is / and then my username for my personal GitHub is GIN-G. So I'll put that in there. And then my repository name I use here is nbviz-2-container- my username. So that should be unique for the repositories that you all forked. So once you've got that in place, you can either paste in your access token that we just generated into this GitHub runner. You can see that I actually do run an environment variable. Typically when I run this, so I've referenced a variable that I've got set for my local environment, so I don't have to paste it in plain text, but I'm going to go ahead and paste in that new token that I've got, just so that you all can see how that works, and you can do the same. So we've got Docker run. I'm giving this container privileges so that it actually can mount Podman volumes and things that it needs to do some sysadmin things that it needs to do in order to build a container inside of this container. That's why we have to give it the privilege flag, because we're doing a Podman in Docker kind of setup here. If you were to run a GitHub action that maybe just ran some Python scripts or some shell scripts and you didn't actually need to build a container image, you could do a self-hosted runner that was built on, Ubuntu latest that included the packages you didn't need, or the packages that you needed for whatever you're trying to do. You wouldn't need to include the privilege flag. So anyways, I'm going to go ahead and hit enter, and it's going to run that start command. So it ran the wget or the curl command that it ran to grab the tarball from GitHub. It extracted that tarball. It ran an installation process. It goes ahead and it connects to GitHub. It uses the API token that I provided when we ran the command to actually get a registration token. So it uses that registration token to then register to GitHub. It does a bunch of defaults as well. If you wanted to specify the name of your runner, you could run, instead of doing just Docker run, you could do like a Docker run -I to run it like in interactive mode. And you could name the runner yourself. You could provide labels, that type of thing, any other settings. The defaults are usually just fine. So at this point, we've started a self-hosted runner on our local machines. It's connected to the repository, and you can see right now it's just sitting there listening for jobs. So this machine will just kind of stay up and run, and it'll wait for I believe it's just like a webhook. It periodically checks into the GitHub Actions to see, do I have a job waiting in the queue? So, and then if I switch back over to my browser, if we go back into the repository settings where we were looking at the runner instructions on how to actually install a runner. Here, so I'm going to go back over into the IDE. I navigated away from the repository, so I'm going to go into the little burger menu and just go to the repository to open that up. Now, if I go over to settings and down to actions and runners again, this time we'll actually see, hey, I've got a runner. It's a self-hosted runner. It's a Linux one, running x64 architecture. Right now it's idle. And this is the name. This is the name that was automatically assigned. It matches up to what was in my terminal output. So right now we have a self-hosted runner that's up, connected to the repository, and it will accept jobs. So at this point, does anybody have questions, or is anybody having issues connecting a self-hosted runner to their repository?
So this is using your current machine to run a GitHub action. Is there a way that we can just pay GitHub more and not be limited by?
Yes.
Okay.
Yes. So we have like an organizational license through NCAR that, again, does provide access to their runners that have, a little bit more, I think a little bit more resources than general, but you can pay for, a better enterprise license through your GitHub subscription that allows your organization access to beefier machines. But I mean, you could also, if you wanted to, you could spin this up on like a AWS EC2 instance. You could run it on like EKS. If you wanted to run it on a Kubernetes service on a cloud provider. We've touched on potentially trying to run this on like HPC environments. This one in particular, because we're doing container image builds inside of a container, requires some elevated and permissions things that causes some issues with running directly on HPC systems. But again, if you were trying to run like some Python scripts, those types of things, I think that would work just fine, because you can run Podman containers on HPC. You just can't run like a Podman in Podman or a Docker in Podman. Like, we're getting into nested virtualization, and it creates a little bit of issues. But you could run a self-hosted runner in Podman that did just some general Python stuff for shell scripts, or maybe you wanted to build a Jupyter book website, something like that. You could run that on HPC systems. I have also set these up to run on the Sizzle on-prem cloud pilot system. So It's basically just hosted on the Kubernetes cluster. It's connected into a repository. It sits there idle until a job fires off. But it has access to all of the resources that those machines have. So like 500 gigabytes of RAM and tons of CPU, GPUs as well. So that's the nice thing about doing it inside a container. And this whole workshop, right, is around kind of building containers and how you can use containers to run these things in different settings. So again, I built a self-hosted runner image to do container builds that I shared with everybody. And you didn't have to build it yourself. We just ran the command. Everybody got to just do it on their own. And now we've got a self-hosted runner connected that's using your laptop resources. And I don't know if anybody noticed either. I'm on a Windows system here, but all of the commands that I have run so far from my terminal window are actually on an Ubuntu VM that I run inside my system. So I'm doing more nested virtualization. But anyways, that's why this self-hosted runner shows as Linux and not Windows. I think that's also because the Podman container that we run is built on top of Debian. So the actual container itself is a Debian container. So any other questions? Awesome. So let's go ahead. Well, I've still got this open. Let's go ahead and disable the other workflow that we had set up to build and push the container image, just to make sure that that does not run. So if you go back over to the repository, click the Actions tab, and then select the workflow that's not disabled. Again, the upper right-hand corner, we've got the 3 dots. Click on that, disable the workflow. So both of our current workflows that we've got are disabled. If you wanted to, you could delete the YAML files out as well. I like to keep them in there for just posterity. But anyways, we at this point, we've got our self-hosted runner up, connected. It's waiting there. So let's go ahead and create a new actions workflow that actually uses that self-hosted runner. So process is going to be the same as we've done the previous 2 times. So let's go ahead up into that workflows folder, right click on that, create a new file. Let's call this self-hosted test. Again, whatever you want to do works for you. Then back over in the notebook, let's double click on the cell to get all the text that we want. Make sure you don't grab the backticks and you're grabbing just the code block. I have found the scrolling inside the GitHub Dev IDE to be just a little bit janky, but it works really well for these kind of workshops so that we're all working out of the same kind of interface. So anyways, copy the contents of the self-hosted workflow, and then let's paste those into the self-hosted YAML file that we just defined. We'll go through again real fast the stuff that we've already touched on. So again, first step, let's set the name. The default name that I've given you all is workshop self-hosted build and push. So that'll be the new name for this. We're gonna trigger this action the same way we did before. So any push to the August 8th, 2024 directory on the main branch will trigger this action. And now we're gonna get into the job. This job is gonna be a little bit different before because we're on a self-hosted runner. So the self-hosted runner can use those community developed actions. So we could use and we do use the actions checkout to actually clone the repository contents into our self-hosted runner. So let me back step just a second. So this line 20 is really the important bit that we've changed so far. So before we selected runs on Ubuntu latest. We're not doing that anymore. We want to run on our self-hosted runner. So we just say, hey, run on self-hosted. If we wanted to, we could open up multiple terminal windows and start multiple self-hosted runners. We've only got one, so it'll run on that that one self-hosted runner that we've got connected. So like I mentioned before, step one remains the same, as before. We're going to use the actions checkout community, job to our community step to clone the repository contents into our self-hosted runner so that we can actually use the code that we care about to build the image. Step two, we're going to do the same thing and we're going to get that current date. If you look at this one a little bit closer, we're actually doing this dot percentage sign with a capital M. Previously, we did year, month, date, dot hour, and I'm adding in dot minute here to make sure that we don't have any conflicts because we're getting close to building an image that's happening in the same hour. So it would just overwrite the current image that we built, just gives us a little bit more granularity in our tag. Now, where things really change are the next steps. So again, this is a Podman image. It does not have Docker installed on it. So if we were to use the same Docker, step that we did before, that community Docker build and push step, it would be able to go and grab that job, but when it ran the Docker commands, it would say the Docker daemon isn't started. Are you sure that it's running? And we don't have Docker. So what we're going to do instead is we're actually going to run these commands like we normally would. So this step 3, the job name is build and it's build and push the image, but this is really just build the image. And so we're going to run Podman commands like we normally would to just build our image locally. So I know we haven't really touched on these steps in this workshop. We went over it in much greater detail in the previous workshop. So I'm not going to spend too much time on the syntax, but anyways, we're going to say name the job, and then we're going to do run. So this is just going to run like we were in the terminal window, just regularly on the actual machine. So the command that we would type into the terminal on the Linux machine would be podman build. We'd give -F for the file, which is in the August 8th, 2024 directory. And our file is named container file. That's the container image file. The -T is tag the image. And then that's going to be docker.io for Docker Hub. Then /. At this point, we're going to go in and delete encode and update this to be your registry name. So again, the registry name that we grabbed before. Mine is NCJames. Yours is going to be your own unique one. And then the container image name, again, we're just going to leave it workshop-web app. Pull the date time formatting from earlier. It's handled the exact same way that we went over before. And then this last little spot is determining the context, the build context. So we're building out of the August 8th, 2024 directory, period. So that just sets that context. So that step right there will run the podman build command. So when we watch the action, that will have its own full step. It'll go through that whole build command. When that build is finished, it'll jump on to the next step. The next step that we've got defined in here is to use podman login to log into docker.io, use the Docker Hub username and the Docker Hub token that we already set up in secrets. So we don't need to do that for this step. So it'll just reference those and log us right into Docker Hub. And then the final command will be to push the image to Docker Hub. So this last line, we also need to update the registry to make sure that the registry name matches your personal registry. So again, that final command is podman push with the full kind of image, fully qualified image name. So before we push this, is there any questions about the steps that we took here? Awesome. So we're going to go ahead and over on the left side, we'll see the source control extension. The Git extension's got one pending change again. So we will go in there. We'll type our message, add self-hosted job. And we'll commit and push that. We're going to be in the same boat that we were before, right? this job's only going to get triggered whenever we make a change to the August 8th directory. So if I click on the Actions tab, you see we've got a new workflow added, but we don't have any jobs in the queue. So we're going to go ahead back in the IDE, just go ahead and update that container file again, add a comment, delete comment, whatever. I'm just going to undo me deleting the change from before. So we can see I undid that change. I got now a change for my container file that I can commit. So I'm just going to say trigger new workflow as my commit message and commit and push that container file. So this will trigger that new action workflow. I'm actually going to switch and present my whole screen at this point. The reason I'm going to do this is so that we can see, hey, if I go back over to the actual repository inside Actions, right? Got this new workflow. Click on that. Here we go. It's already up and running. It's going through the same steps. It's going to look exactly the same as before. It's already at the build and push image job step, but this is when it's just doing the Podman build. And if I open up my terminal, I see that the self-hosted runner actually has a new line in the output, and it says, hey, I'm running this job. It's called build push -sh runner. So, build push self-hosted runner was the name of the job that we provided in the Actions workflow YAML file. So this self-hosted runner really doesn't give you much other information outside of that. It's going to say, hey, I'm running this job. It'll tell you the job completed successfully. It'll tell you the job failed, but that's it. You really can't get in-depth logs from that. You're really going to want to come back to your browser window, and inside this Actions job summary, this is going to be your logs for the job. If something were to go wrong, this is where you would look through the code to kind of figure out what that issue was and how you can correct it. So at this point, Podman's still building the container image. It's the same image that we did before. No changes. So everything should still kind of run exactly the same. But again, we're using your actual machines and building this image inside of the Podman self-hosted runner. So while we wait for this to build out, is there any other questions about self-hosted runners, kind of where you can do them, questions about limitations, anything else like that? Like I mentioned before, I built this self-hosted runner specifically for a use case that I had. Again, I was building some GPU based, or some images with GPU packages inside, and they just got too big for the GitHub provided runners. So I started exploring the self-hosted runners, did it right inside of a container right from the jump, and did a little bit of trial and error to figure out, the packages required to fit my workflow. So I kind of fire this up, run through a test workflow. It would fail, and said, oh, this, maybe it was like Python isn't installed. And I'd say, okay, I got to go back and actually run, a yum install Python. Or maybe at the time I was doing Ubuntu, and maybe it was Git wasn't installed, so I had to do an apt-get install Git. Those types of things. But anyways, this job finished. You can see it's kind of has a lot of the similar output to before. We successfully tagged our image. You can see that it is hiding my username and password here when it goes to log in. So I don't, like I touched on before, anything that we add to the Actions secrets gets fully encrypted. That never shows up in plain text. So anytime we reference that variable, you can know that hey, that's hidden from view. I know that that's safe and secure. If we jump back over into my Docker Hub and refresh this page, here we go. Here's the new image pushed just about a minute ago, and you can see that it's got the minutes added to the tag, where the previous one just had the hour. So at this point, we have just built a container image and pushed it to Docker Hub with a self-hosted runner. So that's really the end of the introduction to using GitHub Actions, the GitHub provided runners, and using GitHub self-hosted runners to build container images. There haven't been any questions up to this point, but we're going to transition over to talking about Helm charts a little bit. So I want to take this as just another point to stop and say, is there any questions about the GitHub Actions workflows, the actual runners themselves, creating self-hosted runners? Any questions along those lines when it comes to automation using GitHub Actions and the runners, either the ones they provide or self-hosted?
I do Brian first.
Okay. Go ahead, Brian.
Yeah, thanks. I guess I'm just curious with the containerized build that you have here using Podman, are there any either explicit or implicit resource limits with this approach? Like I'm thinking about the temp file system, and memory, or are those just sort of what you have on the self-hosted system or on the VM that you're running in?
Yeah, it would come back to the hardware that you're running it on. I did not define any kind of resources inside like the actual container file or anything like that. I will say when I deploy these to like the Kubernetes cluster, so the on-prem cloud system, I do provide resource limits when I do that. And I could put in some resource limits when I actually launch that command. Otherwise, I believe that, everything else that my system limitations get passed on to that container. That makes sense.
Yeah, thank you.
Okay. Yeah.
Who's your median user at NCAR for this workflow? Like we use GitHub Actions for some CI/CD on like internal repos and stuff, but like this just seems like the next step. So like, I don't.
So I really have been looking at this like, interactive web visualizations, those types of things. Like, this is relatively new territory and new capabilities. So, if you're developing a interactive visualization, the example that I provided, right, is visualization of some ERA5 data. But it's fairly limited. We only got 2 meter surface temperature in there. So if I wanted to do some initial, like some continuous development, add in some different variables to that plot, add in some HTML formatting to make the website look a little bit nicer, those types of things. It would be, hey, you get this workflow set up, you build your initial container. As you continue to develop, you push those changes to a repository, it builds a new image, you can test that image, or it automatically kind of updates a test website for you, those types of things. So I'll get into that a little bit when I do the Helm chart discussion.
Okay. It seems like public/web facing is going to be like, that's like the common thread I'm pulling on so far.
Yeah, possibly. I think that you could use this though, like if you're doing a containerized like API server, right? And then maybe that API actually calls, maybe that API is configured to run some commands on like an HPC system and return some information. You could do that as well. you could do an API development. You could add in additional API endpoints. So right, like maybe you start off with a pretty basic API that only does a few things, but you do development to add in additional API endpoints. We're doing really simple applications here as well, but you can have a pretty in-depth application, right, that has multiple databases that connect back to a front end that's different from your API server. Like you can make this pretty complicated, and you can then split those different components up into their own containerized microservices. So like your front end is its own container, your API is its own container. You know, you have 3 different databases that's its own container. And so that's really kind of how I have envisioned all of this stuff, as like a way to do some CI/CD for active development of a publicly facing website, or maybe some backend API stuff that calls. And maybe we're doing reading data off of Glade, but we only give it access to certain or certain directories to start. Those types of things. So I really look at this as a way to enhance that development by providing a way to build these containers, to test them out before you were to kind of push them into production. So I have a note at the end of the walkthrough. We've done everything out of the main branch so far. Typically, the way that I do these for I have a website that I've been doing is just like kicking the tires on a couple different things. I have a test version that I run out of the development branch. So I'll make changes to that development branch. It will run a job to build the container. When that container successfully builds, it'll actually open a PR for me to merge those changes into main. When I do that, it'll build the container image and push that, and then update my Helm chart file, which will automatically sync. So we'll get into that a little bit more in detail as we talk about Helm charts. And I think we're mostly going to talk about Helm charts and kind of walk through an example of what that looks like and how you could use this workflow to update those automatically. So we'll get into a little bit more depth there, but does that kind of answer your question?
For sure. Yeah, no, I think it's helpful. That's definitely helpful, and I'll save it for the end.
Yeah. And again, it's there's a lot of different opportunities, right? And a lot of different technologies and things that you can utilize here. So I'm providing one example of like building a container, but you could do this to, again, update some Apache website or something like that instead. It doesn't have to just be containers. So, I do have another note too about the self-hosted runner access. So I'm here at the Mesa Lab, and I am connected to the UCAR network. So my self-hosted runner actually has access to the other devices on the UCAR network. So for instance, the Sizzle Cloud Pilot hosts a container registry that is only available currently on the inside of the UCAR network. So because my self-hosted runner is on that network right now, I can actually push my container images to that self-hosted, Cloud Pilot container registry. So right here, this hub.cates.ucar.edu. If I was at home and not on the VPN, I can't access that. So my self-hosted runner wouldn't be able to push there. But because I'm connected to that network on my laptop, my self-hosted runner has access to that system. So it can push to that machine. Again, if I wanted to use SSH keys to SSH into like a different machine to run a script or something like that, I can do that from the self-hosted runner on this network now. So again, it opens up a little bit more flexibility what you can do. Again, we're doing this as this use case is let's build container images, but it can really be extrapolated to do whatever your workflows provide you, or whatever they bring up on the day-to-day. So so that being said, we're going to jump into talking about Helm charts for a little bit. So I think at the start of this, I mentioned Helm charts And if you've never used Kubernetes before, and just so everybody knows, just an introduction to Kubernetes. Kubernetes is a container orchestration platform. Actually saw it, it had its 10-year anniversary the other day. So it was actually originally developed at Google. And it went through a number of different things. I think the first instance at Google, they called it Borg. And it evolved into Kubernetes. And Google basically put this Kubernetes container orchestration platform out to the rest of the world, and said, hey, this is an open source platform. It's really, really great at doing some self-healing, resource management, scaling. It's really a great platform that you'll see most, cloud platforms and stuff. They're probably running a Kubernetes under the covers, and even like your Google search, right? Your Google search runs Kubernetes kind of under the covers. When you do a search, it actually spins up a pod in a Kubernetes cluster to run your search for you, and then it tears that down when you're done. So it handles a lot of this container management for you. So again, if you have a Kubernetes cluster that has multiple nodes in it, one of those nodes goes down, it will reassign all of your workloads to a node that's up. The end user has no idea that they lost a node, that their workload actually got reassigned, those types of things. So it creates a really highly available, robust platform to run these kind of workloads on. And one of the ways that you can install applications on a Kubernetes cluster is through what's called Helm charts. And a Helm chart is really just it's a directory that contains a set of configuration files for your application. It's all done via YAML, so they're all text-based files in YAML format. So it makes it pretty easy to read them. You can set up variables and things like that as well. So we'll get into that in a little bit more detail. So the Helm chart that we're going to take a look at contains configurations for 3 different Kubernetes objects. So to run like a simple web application on a Kubernetes cluster, there's 3 objects like I just mentioned. And those objects are called a deployment, a service, and an ingress. So the ways to break this down is the Kubernetes deployment is the actual application. It's running in one or more Kubernetes pods. A Kubernetes pod is the smallest unit inside of a Kubernetes object. But a pod can run more than one container inside of it. So pods are different than containers. You can think about them kind of in a similar way, but one of the bigger takeaways there is your pod can run multiple containers underneath of it, and a deployment can run multiple pods. It basically also can run different. You can set it up to run replicas of your application as well. So let's say you are doing an API and you're worried about people really hitting the API pretty hard and running up the resources on one instance. You can set it up to run 3 instances of that API's web server, and it will automatically load balance the traffic for you so that you don't actually have to think about it. And you can do all of those things dynamically as well. You can, change your Helm chart to say, I'm currently running 3 replicas and now I want it to run 5. You can change the amount of memory and CPU you want to use, those types of things. So we'll get into that a little bit more when we look at the deployment YAML file. The service object is what actually connects your applications and your pods to the Kubernetes network. So you can have your deployment, it runs isolated until you define a service. That service then exposes your application to the Kubernetes internal network so that it can talk to different applications on the Kubernetes internal network. So Kubernetes itself runs a private network inside that's not exposed to the outside world. It exposes things to the outside world via an ingress. So this Kubernetes ingress then will map the service that we set up to a fully qualified domain name, and it will expose it outside of the cluster. So these are all things that we have already set up on the Sizzle on-premise cloud pilot. If you were to, there's a number of different Kubernetes providers that you can run on your own. So I've run a number of them, and it'll create a small Kubernetes cluster for you on like your local machine. So you can run something called Minikube. There's another one called K3S. There's a couple others as well that'll run a Kubernetes cluster for you on your own personal machine. So if you were to set that up, you'd be able to run a deployment. You'd be able to run a service without additional configuration, but you would need to install the ingress yourself, which is a little bit more of a high-level Kubernetes task, but it's something that we've already configured on the Sizzle on-prem cloud pilot. So you don't really need to worry about setting that up. You can just take advantage of the ingress that's already in place. So I feel like I just touched on a bunch of stuff that's probably new to people. So does anybody have questions about Kubernetes, the Kubernetes objects, any of the things that I just talked about before we kind of look at these different YAML files? I think looking at the YAML files will help kind of explain what's going on a little bit more. Awesome. So over on the left, I've included this web app Helm chart directory, and this is just a simple web app template that you could fill out on your own. I copied it basically from another repository that I have. I've created a couple different Helm chart templates for different use cases. So this one's just a template for a simple web application. I have another one that's a web application template, but it mounts a volume. So for instance, if you wanted to mount Glade read-only inside of your container, it's a template for that. I have another one to start up Dask clusters. So on Kubernetes, you can actually start up your own Dask cluster with its own workers that are separate from your application. Then you can connect that. So I have a number of different Helm templates. This one that we're going to look at is just a simple template. And I think some of the topics that I've potentially touched on are slightly confusing. And Helm makes it really nice by providing a values file, so that we don't have to look at these large, deployment YAML files that really get into the nuts and bolts of what we're trying to do. The values file provides just a nice template for what's important for your application. So again, for this web app, we can go through. We'd want to define a name for our web app. So I like to use something descriptive like Encode workshop web app. Spelling right. We can give it a group label. So I typically like to just give it the same as my app name. But if I was developing a more complicated app, maybe I would just want to leave this, Nick Cody workshop. And I had a database that had a different name, then I could add it to this group. The URL path is going to be the suffix of the actual web application that we're developing. So for more standard web applications, this is just going to be like a /. That's like the root of our application. But for instance, if you're doing like fast API development or something like that, your root path might be like /v1/API or something like that by default. So you would just want to put that in correctly. You would have to know your particular application. So the container that we just ran, the path, the default path is just /. The next part is around certificates. So this is where we would actually want to provide a fully qualified domain name for our application. So this is something that the Sizzle on-prem cloud pilot has configured to assign for you automatically. So if I go ahead and do my web app name and then add .cates.ucar.edu, the Sizzle on-prem cloud pilot has a DNS provider that's hooked into the UCAR DNS that will go ahead and create a host record, so an A record inside a DNS for ncody-workshop-web app underneath the .cates subdomain automatically for me. So I don't have to create that host record. It'll go ahead and create that for me. When I delete this application, it'll delete that record for me. So it really kind of streamlines that whole process. Again, at this point, we only have that DNS set up to provide records underneath the .cates.ucar.edu subdomain. So any names currently have to work underneath that subdomain. If you're interested in deploying somewhere else, we could have a conversation about opening up different subdomains to deploy to. But that's where we are currently. And then the next piece underneath this TLS is the secret name. And this is basically, we also have a certificate manager installed on the on-prem cloud pilot cluster. So not only will it provide you a DNS name, it will actually get a valid TLS certificate for that DNS name and apply it to your application for you. So this will give you a fully qualified domain name URL that you can browse to that's fully secured with a TLS certificate for your particular address that's valid, that will provide you HTTPS encryption basically right from the jump. So we don't allow port 80, we don't allow HTTP traffic. So this will set you up with a full URL with a certificate and everything automatically. You don't have to do any of that. You just fill out this form basically. So this secret name needs to be unique for your fully qualified domain name. So I again usually just like to provide the web app name or that I'm using to define this. And again, if I were to, let's say I built a front end, and it's built on Flask, and it's just that /, and that's its own application, and then I develop another Helm chart for an API, and that path is at v1-API. I would provide the same FQDN and the same secret name because it would want the same secret name for that FQDN. And I hope that makes sense. The secret name is tied to the FQDN. So anytime you want a unique FQDN, you need to provide a unique secret name. But if you want to reuse that FQDN, provide the secret name that you've already used, and it will already use that TLS certificate that was applied to the previous one. So the next bit we're going to get into comes down to the container. So this kind of touches on Brian's question earlier about resources. This is where you would define, the CPU and the memory that your application needs. We have a pretty, minimal web application. So 1 CPU and 2 gigs of memory should be okay. In the command that we ran earlier, when we actually started this container up locally, we know that this runs on port 5006. So we want to provide that port into the Helm chart. And then the last bit here is image name. So this is actually going to be the image that we created as part of our workflow earlier. So we can go ahead and grab that from either the command line or our action job or the Docker Hub itself. Just copy this tag. Copy that. In here, I'll just do Docker IO to specify that's the registry I want to grab it from. then my actual registry name, and this is workshop web app with the current tag. So at this point, I've provided all of the unique values for my application. So again, if you all were following along with me, this would be unique for the builds that you just did, unique for the name that you wanted to provide. And so we have Helm charts that are ultimately building the same application, but have unique values for our deployments. So what this values file is actually doing is providing these variables as inputs for YAML files that we have defined in our templates folder here. So over on the left, if we expand open this templates inside the web app Helm chart, you can see that there's definitions for our 3 Kubernetes objects that we talked about earlier. So we have one YAML file for the deployment, one for the ingress, and another for the service. And if we click on this, we'll go into the deployment. You can see it starts off a API version. That's the Kubernetes API that we want to use. Apps v1. This is the kind. So what kind of Kubernetes object are we defining here? So this is the deployment file. And this is going to be our Kubernetes deployment object. And then we get into some metadata like the name, the namespace, labels that we want to apply to the deployment. So if you look inside these double curly braces, we've got dot values. So that means look at my values.yaml file in the base of my Helm chart. So this variable is going to look into the dot values, and then it's going to look at web app, and then underneath web app, what's the name? So if we go back, we look, here's web app. Underneath that, the dot is the next indentation. There's the name. It's going to populate that variable with what we define in the values file. This release.namespace, if we were to do a Helm install, we would provide it a namespace, and it would use that namespace to fill this field out. We're not going to get to that point today, but just as an example, that's where it would pull that from. So whatever namespace you installed your Helm chart into, it would pull that and automatically fill out this deployment file. So the labels, it's going to pull the web app name in the group, just like we defined earlier. Then we get into the specification of the deployment, right? And this is kind of the nuts and bolts of actually what we want to do. So we go right in, we say select apps that match the labels, which we define as the web app name. So anything that's part of that is anything that has that label is going to be part of this deployment. We're going to take a template, assign the metadata with the labels again, so that all of our labels match across the board. And then we get into the spec for the template, which is actually the containers that we're going to run. And again, under here, you could define multiple containers. Let's say, for instance, the deployment was a web application with a database. You could start a container underneath, and then you would just do a dash name with a new database name, those types of things. And you would just expand your values file out to follow that similar syntax, where maybe instead of web app, would say database, right? And you'd start that from the very first indentation, down here on line 13. But anyways, it's going through and it's pulling the web app name, the container image, the memory, the CPU, the container port, and it's assigning those all directly to the deployment file without the end user really having to go in and looking at the deployment file. I wanted to go through it with you all while we have this time, because it's important to kind of understand what's going on behind the curtains. This is, again, a Kubernetes object configuration file. If you wanted to, you could fill this out hard-coded, and you could use a kubectl apply-f command and give it this deployment.yaml file. It would install it the same way. But we package everything together in this Helm chart so that we can update only the values file and make it a little bit more straightforward for the end user. So if we look, let's go to the service next, just because that's next in the logical progression, right? So we've got this deployment. It's running inside our Kubernetes cluster, but it's fully isolated at this point. We can't talk to it. Kubernetes can't talk to it. So we have to define our service, and it's going to use a lot of the same values that we defined, right? So it's going to take the metadata to give this service a name. The name's going to be exactly the same as the web app name. It's going to be deployed in the same namespace as the deployment. We want all of this stuff to be deployed in the same namespace. We're going to group them all together with the same label. The specs on the service are pretty straightforward. We're just going to say, hey, expose this port and give it the container port, so 5006. Expose this port to the container or the Kubernetes network. And then again, select based off of the app that we named earlier. So this will go out, select the web app application name, and expose that port 5006 on a service. So at this point, Kubernetes will be able to talk to the application via port 5006. Kubernetes, again, has its own network. So it has its own internal IP address that it uses. It's like a 10.40 address, private network space that it uses to route all that traffic. So this connects that. At this point, if you were to go into the cluster, you could access the application on port 5006 once this service has been applied. So it's still not exposed to the external world, though. That's when we use this ingress. So this ingress is going to have some hard-coded values that are, again, specific to the Sizzle on-prem cloud pilot. But we kind of go through the same thing. We select our API version for the networking, specify the object kind. So this is the ingress object. Go through our metadata, give all of our metadata kind of the same stuff, right? Same group, same name. Again, this will be named the same as the web app, but underneath the ingress objects. But there is, you notice right here, there's this annotations line underneath the metadata. And then it says certmanager.io cluster issuer in common. And that is just the cert manager that we have running on this cluster. Again, so that the ingress knows, hey, go talk to this certificate manager and ask for a certificate with this fully qualified domain name. So we have that hard coded just because that's the value that we use for this cluster. If you were to try to use this Helm chart in a different cluster, it might use a different issuer or something like that. So you would want to change this, but for what we're doing, this is the default value. So same underneath the spec. So under the spec, we have to define the ingress class name. There's a number of different ingress classes that you can use. For instance, I mentioned K3S as a option to run a Kubernetes cluster on your own system. It uses a ingress called Trafic instead of Nginx. If you've done any kind of web app development for a long time, though, you probably heard Nginx around for a while. It's if you were to do a web server on a virtual machine or a bare metal server, you would use Nginx as your reverse proxy, which basically connects your fully qualified domain name down to your actual application at the port level. So we specify, hey, we're using Nginx as our ingress because that's the ingress controller that we have installed on this Kubernetes cluster. So again, if you were to use something different, that would change. But for our use case, this is the default version. This is what we want to share with everybody else. So, and then the next couple of lines are around TLS. So again, what's the host name that you want to assign a certificate to? And then where do you want to store that secret information? So it's going to go ahead and talk to cert manager, say, hey, cert manager, I want a TLS certificate for this fully qualified domain name. Cert manager is going to issue that. And then Kubernetes is going to store it underneath that unique secret name so that we can reference that TLS certificate for different applications if we want to. It'll pull that out instead of having to reissue a certificate. So, and then that cert manager also will do lifecycle management of our certificates for us. So we don't have to worry about, oh, our certificate expired, our website's no longer secure. Users are going to our website now when they're saying, their certificate's not valid and They have to type "this is unsafe" to proceed any further. We have to get our sysadmins in there, get a new certificate, update everything. You don't have to worry about that anymore. The Cert Manager Kubernetes tool does all of that for you, which again is, if you've ever managed certificates and everything and lifecycle management of hundreds of websites or whatever, it's really a godsend, and it makes things really easy. Again, you don't have to do the DNS management as well. So that's part of this next bit, where the rules are what we're going to assign to the ingress. So again, our host name is going to be the FQDN that we set in the values. We're going to say we're going to do HTTP rules. It's going to move everything to HTTPS, but they're just inheriting those. We're going to define the path. So again, this is just the / that we assigned earlier. The path type in the Kubernetes object is a prefix for that, which seems a little bit backwards, but that is the correct type just to set that prefix path. And then we configured the backend a little bit, and this is where we provided the service to connect to. So this is our ingress controller. So the ingress controller actually has only one IP address, and it routes all of the FQDNs through that same IP address. So again, if Thomas, you had your own website, I have my own website, they're going to have the same IP address, and they're going to get routed through the same ingress IP, but the end point is going to be that service that we defined earlier, and the FQDN is basically how it knows to get there. So that FQDN is unique. We go to that FQDN, we get hit to the ingress at the same IP, and then it's going to route us here at the bottom to the service name that we defined and the service port that we defined earlier. So that's kind of this simple web application in a nutshell. So any questions about the Helm chart and the different Kubernetes objects that we've covered so far? Go ahead, Brian.
Yeah, if I follow correctly, if different apps are running are being served through the same IP, do you have to worry about port collisions?
No, because of the namespace isolation. Typically, if I installed an application, I would do it in my own personal kind of namespace. If you deployed one, you'd have your own namespace for it. If, for instance, we were working in the same namespace and you had deployed an application running on 5006, and I tried to apply this Helm chart on top of what you already had deployed, I would get an error saying that service already existed on that port. So, but I could also set it up where I can map my container port to a different port inside of Kubernetes. So I can run a container on port 5. We can run 10 ports on, we can run 10 containers on port 5006, but map them to different ports on the Kubernetes network and expose them on different ports on that network. So if you do have a collision, it would let you know, and it would not deploy those resources for you. But otherwise, you can run things on the same ports in different network spaces, because the service will actually get a different internal IP address, and then it will route that traffic down to the unique IP address and port for that particular service. That cool? That makes sense?
Yeah, thank you.
Cool. And then Carl asked if there is an actual chart, a graphical representation. And there is not a graphical representation. There isn't, from the way that we've gone through things so far, there is not a graphical representation. It is kind of laid out this way. They do call it Helm because of, some tiebacks to, being a mariner or, a sailor and out there and at the helm of a ship kind of thing. And they think of it kind of as, a Helm chart would be similar to like a map that you would use as, a sailor, but there is not a graphical representation of the Helm chart in the context that we've looked at it so far. So when it comes into automating, I'm going to switch gears here a little bit. And if we jump back into the walkthrough, we kind of go through some of this. But I have a blurb here after we kind of talk about what a Helm chart is and what the values are, and updating those. I have a blurb about using GitHub Actions to actually update that values.yaml file. So kind of back to Thomas's question earlier about, how does this workflow fit into development setup? So as part of the Sizzle Cloud pilot, we have a continuous deployment tool called Argo CD. And Argo CD connects to a Git repository and looks at a Helm chart in that repository and automatically syncs the configuration to match what's stored in the Git repository. So it does check in like every 3 to 5 minutes, and it will look at that Helm chart and say, has it changed? No, it hasn't changed. Still the same exact build. So, but when it does change, it will go through and update your application to match the Helm chart that's stored in the repository. So a way that this can be beneficial, right, is if we look at the kind of the ways that we've been doing things so far, right? We're building a new container image for our web application. So, and then we use that container image right here in our web application definition. And we deploy this to the Sizzle on-prem cloud pilot. It's tied into our continuous deployment tool. So it's looking, and we could manually build a new container. We could manually push it up to Docker Hub and get a new tag. And we could go in here and say, oh, I just built another one. And instead of, August 8th.16, we're on the hour 17. I can push those changes up, and Argo CD would say, oh, hey, there's a new image, and I can do all that. What I have done to make this an automated process and more CI/CD is I actually have added in a couple of lines to the GitHub Actions files that we developed earlier, right? So after it pushes that image and it successfully pushes that image, I've added in 2 steps to my workflow file to actually update the values file on its own. So GitHub Actions will actually go through and say, oh, hey, and again, like this command right here uses sed, which is a Linux command to do an in-place line change on line 12 of my values file. So I had to know what line to change. There's other ways that you can handle this. This is just what I've used for my example. But basically what it's doing is I've got a new image that I just built. As part of my automation, update the values file to use that new image, and then commit those changes and push the changes. So this workflow now looks like I've got this web app. It's been running for a long time. I made a change and I want to run a green background on my HTML. So I made those changes. I pushed it to a dev branch. Looks good. My test belt finished. Merge it to main. It goes through. It builds a new image. It updates my web app Helm chart value file to use this new image. And then my continuous deployment tool, once that change has been pushed, sees that there's been a change to my values file and automatically updates my application for me to use that new image. So all I had to do was update the HTML to be a green background, maybe a CSS, right? I go into the CSS, I say, hey, the main background is green now. Push those up into my GitHub repository, go off to lunch. It builds a new container, it updates my Helm file. Argo CD, the continuous deployment tool, sees that there's been a change. It updates it. So when I get back from lunch, I go to the website, my background's green. I didn't have to, build that container image. I didn't have to update my web application, restart anything like that. Like it's all handled automatically for me. And that's really when this kind of becomes like a powerful tool. And again, Thomas, back to your question about like, how do you see this development workflow going forward, what I'll end up doing is I'll actually create like a test site Helm chart, and I'll use that as like, my development site, and I'll hook up Argo CD to be in that one. So when I make changes, I get to test them live in my test site, but my production Helm chart has never changed. And when my test site is good, then I'll merge those changes into main. It'll build a new container image. It'll update my production Helm chart. And then I have a, kind of a blue-green deployment where the test website that I know works before I even update my production website. So it really creates this powerful development pipeline where you can have a production website that you don't change. You can have a test version that you can update real time and collaborate with other people on your team, and really just opens up a number of different things. And then just I've been talking about Argo CD a little bit, and it is an administrative only tool. So typically what you would do is you would create your Helm chart either by yourself, or you could reach out to me and the cloud pilot team, and we could help you kind of get this together for your application. And we would add it into the continuous deployment tool for you. And this mostly this way because of security reasons and that type of thing. Like, we don't want to open it up so anybody can just like add their own applications in. We've got GPUs and stuff running. We don't want like Bitcoin mining going on, or people training their ML workloads and stuff on this without being approved to do that. So that's currently the way that we have it set up. We are doing some investigation to set it up where we would have like a central repository. Let's say we have like a NCAR web visualizations repository that you would actually be able to open a PR and include your configuration in that PR to add it to a centralized kind of repository, so that you wouldn't need to, provide your own repository and these types of things to sync. So that's kind of where we're at, and that's like, I did want to kind of wrap up talking about Argo CD. And again, it's an administrative only tool. But let's take a look at it, because to Carl's question about the, does a Helm chart provide a graphical representation? No, a typical Helm chart does not. But if we go into Argo CD, which actually connects to our Helm charts, then we can see a little bit more of a graphical representation. So this is what Argo looks like, and you guys would never really log in here. This is an administrative only tool, but we would connect it to your repository. We would set up the automation so that would automatically sync for you and all that. And that, once it's set up, you don't really ever have to engage with the administrators ever again, unless there was a problem, you needed a rollback, something like that. You would make the changes to your Git repository. Everything else would update right behind the scenes. So let's look. I have a thought I had a. We can go into my test. So this is kind of what I was mentioning earlier. I do run a kind of like a blue-green deployment out of a repository that I do for testing. So I'll run a development website and a production website, and this one will allow me to do some testing. And this inside of Argo gives a little bit more of a graphical representation, Carl, to your point, where you can see, like, here's the top level Helm chart right here. It's got 3 different objects underneath of it, which is a service, a deployment, and an ingress. And then there's, here's my certificate request. The deployment creates a policy report and a replica set. I'm only running 1 replica. So this replica set manages how many instances it should run. But again, we're only running 1. So you can see the 1 pod over on the end. We got our endpoints and stuff. So here's a more graphical representation. But this is not typical for Helm charts. Helm charts are really going to be just those text files, more of a your traditional kind of file structure look at it. You're really not going to see it in this kind of graphical view unless you sync it into a tool like Argo CD. And again, this is something that only an administrator would have access to. So again, you would have your Helm chart put together. You'd submit a ticket to the team and say, hey, I've got this Helm chart. I want it added to the cloud project. We'd go in, make sure, everything checks out. You're not doing things that you're not supposed to be doing. We would add it in. It would all get spun up. We would verify that it works for you. And we would say, okay, you're good to go. Anytime you make a change to your Helm chart, it'll automatically update. And again, this is set to auto sync, and by default, I think it checks every 3 minutes. So it's not instantaneous, but it's pretty fast. So that's really all I wanted to touch on. If you all are interested and you want to see your web application, your Helm chart deployed on the Sizzle on-prem cloud, and you want to connect it in, send me just an email off to the side with your Git repository address, and we can work through kind of deploying that together. So just so you can see, how that might get kind of spun up. Again, that the initial deployment is going to take just a minute to get the host record populated through DNS. So just because we get it in here, it'll fully deploy on Kubernetes, but you might not be able to resolve the address for 5 minutes until it populates fully through DNS. The certificate gets signed pretty much right away. But if you're interested in seeing how we would deploy the Helm chart that we just went through for your own application, again, it'll be the same application that we've developed here, right? The content's the same, but it can live at your own personal URL, that type of thing. If you want to see that, just shoot me an email. I can add that in for you. We'll basically say, hey, here it is. It's live. Kick the tires on it. And then when you're done, I'll just delete it out. So again, if that's interesting, let me know. But the one thing I wanted to point on, I think the most important takeaway when it comes to automation is you can build into your workflow so that it updates the image used in your Helm chart anytime that you build a new image. So you don't have to manually do that or anything like that. But I guess one other thing I'll add too is when we look at this values, again, the nice thing about Argo CD is if you wanted to bump this up from 2 gigs to 10 gigs, maybe you got a ton of new users that are really interested in your stuff and your website's been crashing and restarting a little bit because it's running out of memory. You could go in and, change this to 10 and apply those changes to your repository, and it would automatically within 3 minutes, 3 minutes or less, upgrade your application or use 10 gigs of memory. So you don't actually have to go in. You can do everything out of the Git repository. So that being said, we've got 10 minutes left of the scheduled time. Is there anything else that people want to go back on and clarify, or questions or anything like that?
Just want to say thanks. I'm not saying I captured every detail on this, but it definitely was helpful.
Yeah, and the nice thing is this repository will be up, so the walkthrough file will be there if you want to go through it kind of multiple times. We are recording this, so Tasia will get that out in just a little bit. So the next couple of days, be on the lookout. We'll have a YouTube link so that you can go back and go through this stuff retroactively. And again, the main goal here is to kind of lay down some foundational work to get the gears turning in your own head about how you might be able to apply this kind of workflow to something that's interesting to you. Again, we've just used some boilerplate web applications, some boilerplate container files, but the real goal is to just be like, oh, hey, I've been thinking about doing an API for this particular thing. And now I have a little bit of the framework and I know how I can kind of go off on my own and get started with that. So again, I am here. Any questions you ever want to sit down and go over this in more detail, I will say after the last workshop, I sat down with a few different people to go over some of the concepts that we covered in a little bit greater detail, just because they had some questions about it, when they got done and were thinking about it. So if you have questions about this content, you want to sit down one-on-one, feel free to shoot me an email. We'll schedule a meeting. We'll sit down. If you want to apply it to your own stuff, again, I'm here for all of that. So don't hesitate to reach out. Otherwise, I don't have anything else today. I appreciate everybody being here, being engaged, and asking questions. So thank you.